Welcome viewers. Today we are going to start with first exercise of chapter 3 mathematics class 8, that is understanding quadrilaterals. So question number 1, these kind of figures have been given and we have to classify these figures. Okay, so first you have to classify which out of these is a simple curve. So a curve which doesn't cross itself while moving on its path is a simple curve. Let's take an example. Suppose we start from this point and keep on moving to this point. We need not to cross anywhere. The line segment did not cross anywhere. Okay, so this is a simple curve. And of course, it has got all the boundaries closed. Okay, so this is a closed simple curve. So let's see which all out of these are again simple curve. So this is again a simple curve because starting from any point, say this one, if we travel, we don't cross anywhere while moving on its boundary, that is on its path. Okay. Now this curve, if you see, of course, if we start from here and we reach here, we don't cross. But how do we reach to this part? We cannot. And if at all, we have to cross this plane. Okay. To reach again and again, we have to move in this path and come to this and come back to this point. So at some place here, if you imagine, we have to cross its own plane. So this curve is again not a simple curve. Coming on to this, suppose we start from this point, we come here, see here again there is a crossing or transection of this line segment on this. Again we move here, also there is a transection. We keep on moving this way, this way, this way, and this way to reach here. So from starting point, if we have to come back to the same point again, we have to cross or transect line segment of this figure. That is, while moving, we are crossing the path of the figure. So again, this curve is not a simple curve. Okay, let's take this one. We start from here, somewhere here, and we keep on moving and we reach to this point. So again, this is a simple curve. Here also, if we start without transecting any part of the line segment, we reach here. So again, this is a simple curve. Similarly, this is again a simple curve because there is no crossing while moving on the path. Here, if we start from this point, or let's take from this point, we have to come to this point again and go back on this line, take it down here, and again we have to cross this and come. So this is again not a simple curve. Okay, so figure number 1, figure number 2, 5, 6 and 7 are simple curve. Clear? Next question is simple closed curve. All these figures are closed because they have got a delineated boundary. Suppose I rub this one, so this figure will be something like this. So this will become an open curve. Okay, and following the definition of simple curve, we have already done in the first part. So 1, 2, 5, 6, 7 are simple closed curve. Clear? Now question C, which out of these are polygon? Okay, so polygon is derived from the word two part. It has got two part. Poly means many and gonus means angle. So polygon is derived from Latin term poly meaning many, gonus means angle. So a figure formed by many angles is known as polygon. So here is an angle, here is an angle, here is an angle. So there are 4 angles. So this is polygon. Here there is an angle, here an angle, here an angle, here an angle, here an angle. So again this is also a polygon. This doesn't have angle. Okay. Coming on to this. So this is not a polygon. Now if you see this figure, it has multiple crossings. So polygon is basically a simple closed curve. Okay, it's a type of simple closed curve, and this is not a simple closed curve. So by definition, it has got multiple angles, but since it is not simple, this is also not a polygon. Clear? Of course, this is circular curve, not polygon. Oval in shape, not polygon. This has got only one angle here, so definition of poly is not satisfied. So this is also not a polygon. And again, this is a circle based figure, so this is also not a polygon. So only figure 1 and figure 2 are polygon. So coming on to the next part, question D, which of the figures are convex polygon? And we take E also, that is, which of these are concave polygons? So what are convex polygon? The polygon where all the diagonals lies inside the figure. Okay, so we take these two polygons, as we previously have seen, these two are only polygon out of these figures. So in this figure, if we join these 2 points, what are these 2 points? Suppose we mark this as A, this as B, C and D. Okay, so A and C are opposite vertices. So diagonal is a line which join 2 non-consecutive vertices. So there are 2 possibilities, one is A, C and other one is D and B. In this figure, both the diagonals lie inside the polygon. So this becomes a convex polygon. Okay, and in this figure, we can have, suppose we label this as A, this as B, this as C and this as D, and we can make this E. Okay, so diagonals will be, we can join 2 non-consecutive vertices which are A and B, and also these 2, these 2. Okay, and similarly ED and EC. So one of the diagonals, that is AB, is lying outside the figure, outside the polygon. So this polygon is known as a concave polygon. Clear? So convex polygon out of this will be figure number 2, and concave polygon will be figure number 1. Clear? Question number 2. So how many diagonals does each of the following have? So figure A is a convex quadrilateral. So this is I have already drawn. So let's see. Let's say this is A, this is B, this is C and this is D. So what are diagonals? They are the line joining 2 non-consecutive vertices. So A and C are non-consecutive vertices. Similarly, B and D are 2 non-consecutive vertices. So a convex quadrilateral will have 2 diagonals. Okay, we can name it at AC and BD. Okay, now second figure is a regular hexagon. Regular hexagon means it has got means 6 sides, and it's regular because all sides are equal and all angles are also equal. Okay, now let's say this is A, B, C, D, E and F. Diagonals will be AC, AD and AE from point A. Similarly, it will be, if we start from here, it will be F to B, that is FB, FC and FD. Okay, now from E it will be EA, that is, we have already mentioned it, AE, and from here to B, that is EB and EC. Okay, so from point D it will be DA, that is AD, we have already mentioned it, and it will be D to F, and we have already mentioned FD, and another will be B to D, so it will be DB. Okay, similarly we have already mentioned CA, and from here we have mentioned only FC and EC, and last will be, we have already mentioned from here as EB, and from here as FB, and from here DB. Okay, so let's see, it has got 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in an hexagon there are 9 diagonals, may it be regular or non-regular. Okay, third one is a triangle. So this is A, B and C. Does it have any diagonal? No, because there is no non-consecutive vertex. So for A, C is a consecutive vertex and B is a consecutive vertex. So a triangle doesn't have a diagonal. Clear? Question number 3. what is the sum of measure of angles of a convex quadrilateral? Will this property hold if quadrilateral is non-convex? Let's see. So this is a convex quadrilateral and this is a concave quadrilateral. As I've already mentioned, it has got 4 sides, so we can label it as A, B, C and D. And all the, if we dot diagonals, the diagonals will be inside the polygon. And in this case, one of the diagonals, that is this one, will be, let's name it as A, B, C. Okay, this as C and this as D. So one of the diagonals, that is BD, will be lying outside the figure. So this makes it a concave quadrilateral. And one more thing, one of the interior angle, okay, that is angle C, is more than 180 degree. So C, in this case, angle C is greater than 180 degree. So that makes it a concave quadrilateral. In this case, all the interior angles are less than 180 degree. So this makes it a convex quadrilateral. So let's see. Suppose we draw a diagonal. Okay, so this diagonal divides this quadrilateral into 2 triangles. One of the triangle will be A, B and C, triangle A, B and C. Another will be A, D and C. So I got 2 triangles which has combined to make this quadrilateral. Sum of all angles of a triangle is 180 degree. So this angle, this angle, this angle will be 180 degree, and this angle, this angle, this angle. Sum of all these 3 angles will be 180 degree. So for this, some angle will be 180 degree. For this triangle, it will be 180 degree. So for this quadrilateral, it will be 180 plus 180, that is 360 degree. So sum of all the angles of all the interior angle of a convex quadrilateral is 360 degree. Another way of looking at it as, what are the number of sides of a quadrilateral is 4. So we can calculate in another manner. We subtract 2 from the number of sides, that is 4. So we get 2 and we multiply this with 180. So that we get 360. Okay. Moving on to the concave quadrilateral. Let's draw a diagonal here. In this case also we got 2 triangles. So sum of all the interior angles of this quadrilateral will be again 360 degree. Clear? So this property holds true for both convex and concave quadrilateral. Understood? Question number 4. This figure has been given. The first one, there are 3 sides. So we have to find out what will be the sum of interior angle of this polygons. Okay, so this is triangle, and triangle has got 3 sides. So we have to subtract 2 from the number of sides. Okay, and we get the value as 1, and this has to be multiplied with 180. The result we get is sum of all the interior angle of a polygon. So if n is the number of sides, the sum of interior angle of the polygon will be n minus 2 into 180. In this case, this is quadrilateral, so there are 4 sides. So 4 minus 2 is equal to 2 into 180, that is 360. In this case, 5 minus 2 is 3, so it is 3 into 180, that is 540. And it is an hexagon, 6 sides, so 6 minus 2, 4 into 180, that is 720 degree is the value of sum of all the interior angle of a hexagon. Okay. With this concept, we move on to the question. So if there are 7 sides, what will be the sum of interior angle of a convex polygon? Okay, if it has got 7 sides, so 7 minus 2 will be 5 into 180, so it will be 900 degrees. Okay. Similarly, if there are 8 sides, so 8 minus 2 is 6 into 180, that makes it 1080 degree. Okay. If there are 10 sides, so 8 into 180, that makes it 1440 degrees. Okay. And if there are n sides, so what will be the sum of interior angle? It will be n minus 2 into 180 degree. Clear? Question number 5. What is a regular polygon? Regular polygon is a polygon which has all sides equal and all angles are also equal. Okay, so we can see in this figure there are 5 sides and all sides are of equal length and all angles are also equal. So this is the example of a regular polygon. There are 5 sides, so this is a regular pentagon. Okay, now state the name of a regular polygon with 3 sides. So 3 sides, so this becomes an equilateral triangle. Okay, and because all sides are of equal length and all angles are 60 degree. With 4 sides, it is square because all angles are 90 degree and all sides are equal. And if there are 6 sides, it becomes a regular hexagon. Clear? Moving on to question number 6. So we have to find the value of the angle x. Okay, so we know this is quadrilateral and sum of all the interior angle of a quadrilateral is 360 degree. So 360 minus, we add this, so we get 120 plus 30, 250 plus 50, that is 300. So we get the value of x as 60 degree. Clear? This is again a quadrilateral. This is 90 degree exterior angle, so 180 minus 90, so this also is 90 degree. So we get 90 plus 60, 150, and 220, 360 minus 220 is equal to 140 degree. So this angle is 140 degree. Correct? So in this case, sum of all the angles will be 540. So 540 is equal to 2x to same angle plus 110, 120, 30, that is 260. Okay, so we will get the value of 2x is equal to 280. So x is equal to 140 degrees. So this angle will be 140 degree. This is a regular pentagon and value of on the interior angle will be 540. So 540, there are 5 angles divided by 5. So we get the value of x as 108. Clear? Question number 7. We have to find sum of all the exterior angle of this polygon. Okay, that is x plus y plus z. For a polygon, irrespective of its number of sides, sum of all exterior angle is 360 degree. It may be a pentagon, hexagon, a quadrilateral, or a triangle. So, in both these cases, addition of the exterior angle is 360 degree. Okay, let's see. So, in this case, angle x will be, this is 90, so it will be 90, 180 minus 90, 90. Angle y will be, now this is 30, 90 minus 180, that makes it 60. So angle y will be 120 degree and angle z will be 150 degree. Okay, so we get the value as 360 degree. Clear? Sum of all exterior angle of this triangle is 360 degree. Moving on to this quadrilateral. This is 60. We know sum of all angles of a quadrilateral is again 360 degree. So this is 120, 80, 200, 260 minus 360. So this one is 100 degree. So this will be angle x will be 60 degree. Angle y will be 100 degree. Angle z will be 120 degree. And angle W will be 80 degree. So we get the value as 360. So we have seen, irrespective of number of sides, when you add the exterior angle, we get the value as 360. Clear? So this completes our exercise 3.1. Thank you.